Lucky last, question 8. A particle moving on a straight line with velocity varies with displacement according to this rule, where velocity is velocity in meters per second and s is the displacement in meters. That's interesting. Calculate the displacement at t equals 2 if the initial displacement is 0. Well, we have been a little tricky today, haven't we? Okay, so this is a complex, unfamiliar question, so it's not supposed to be friendly. So just think about it in terms of what's actually happening. Velocity, which is measured in meters per second, which means that now S is your thing in meters, remember? And then T is your units of time. So here, when we're talking about meters per second, we're looking at ds over dt. That is our unit for velocity. Now, they have given us that in terms of square root of 4 plus 4s. Now, normally what we would have in a question is dy over dx, and then there's x in the question. So see how these two don't match? That's your first tricky trick, because that means that normally I would have to integrate to get back to the position, but I can't integrate that until I've got it in terms of the thing that I want to integrate with. So we're going to flip this. dt over ds is equal to 1 over square root of 4 plus 4s. Okay, so what that's done is now I can integrate this side with respect to s, instead of trying to integrate it with respect to t, which won't work because I don't have a t over here to integrate. So to work out our function in time, this is going to give us the time on this side and then our displacement on that side. So it's going to be the opposite to what you're used to. So all I have to do is integrate. Now I'm going to make this integratable by doing 4 plus 4s to the power of negative a half with respect to s. Okay, so now I've got it in this form. I'm just going to integrate. So in methods, we use the reverse chain rule. So I still do 4 plus 4s. So this power up here will plus 1 to make it positive a half, and then this is going to be divided by a half. So that means the 1 will stay there. Normally I'd write the 2 on the bottom, but the 2 will flip to the top like that. And then I take the derivative of this bracket, and then that's going on the bottom. So the 4 will go on the bottom. Okay, the reverse chain rule is written down somewhere. I've forgotten what the formal rule is because we do it differently in specialist maths. And so now that's how I think. Okay, so cross them out and we're left with 2 on the bottom. So now I've got the integral is equal to 4 plus 4s over 2 plus Cody. Okay, so that is a function for the time is equal to that in displacement. So now I can start substituting in to work out what c is. Because we do know that initially, which means time is equal to 0, the displacement is equal to 0. So 0 is equal to 2, 4 plus 4 times 0, square root plus c. So I'm going to take c to the other side. 4 plus 4 times 0 just makes that 4. Square root of 4 is 2. 2 divided by 2 is going to be 1. And then I take this negative back over and I'm left with c is equal to negative 1. So my actual function looks like this. Time is equal to 4 plus 4s over 2 minus 1. Now we can try and use this piece of information. Calculate the displacement at time equals 2. So all I'm going to do is put 2 back in here and rearrange to get s. They really don't give you a lot of space, do they? Okay, so 2 is equal to square root of 4 plus 4 s over 2 minus 1. First thing I'm going to grab is this one, taken back over, add 1. That gives me 3 is equal to square root of 4 plus 4s all over 2. Take this 2 back. Now I'm going to multiply it and it's going to become 6. So 6 is equal to the square root of 4 plus 4s. Take the squared over. 36 is equal to 4 plus 4s. Take the 4. Now 32 is equal to 4s. Take the 4, and I'm left by dividing by 4. Ooh, see ya. 8 equals s. So then at t equals 2, s equals 8 meters. Okay, that is a trickier one, but that's what makes it complex unfamiliar.